Design of reinforced concrete structures, Chapter 4, Flexural Analysis and Design of Beams. Rectangular beams with tensile and compressive reinforcement. So we do have a rectangular cross section which we include the AS, which is a tensile rebars, and also A prime S, which is a compression rebars at the top of the section. So in such case, if we have a tensile rebars at the bottom of the section and a compressive compression steel at a distance of d prime from the top of the section. So if we have epsilon u for the compressive stress, compressive concrete strain, ultimate strain of concrete, and also we do have epsilon s at the bottom, and also we have a epsilon prime s somewhere with a distance of d prime from the top of the section. So in such case, if we want to represent all the forces, we do have a tensile rebars at the bottom, we do have a compression rebar at the top, and we do have a compressive concrete block at the top. So it just says if we want to separate the forces, so we can say we do have, so the total the combination is goes to two different section, which one just have a prime s times fy at the bottom and a prime s times fy at the bottom, and plus as minus as prime times fy, which make a couple with the compressive part of the concrete. So we can consider our section like the overall cross section like a two of them. Each one of them is just include a couple just by a prime s times fy, and the other one is as minus a s prime times fy, and a compressive concrete block. So in which each of them develops its own couple. So, and the scenario, let's go for the simplest scenario, which both a tensile and compression steel both are at yield. So we do have a prime s times fy and also a s in yield. Both of them are in yield condition. So if you develop the summation of forces in x direction, it just says as times fy, the tensile force is the equal to 85% of f prime c times ab plus a compressive part of a steel, which is a prime s times fy. And if you develop the equation based off a to calculate the height of equivalent block when we have a compressive and tensile rebars, and that a is minus a prime s times fy over 85% of f prime c times b. Again, that's a simplest scenario which tensile tension and compression steel both are at yield stresses, and likewise to develop the moment, resistant moment is consists of two part, mrs and mrc, resistant due to a steel and resistant due to concrete part. And the first one is a prime s times fy times d minus d prime, which is this distance, and the other one is 85% of f prime c times ab times d minus a over 2, which is the second part, which is the effective depths minus the half of the equivalent rectangular stress distribution of Whitney. And definitely MR is summation of both of them. So one can say MR M resistance is consists of MRS plus MRC. We'll put it onto example on a next videos. Thank you.